Okay. So last class we have seen that what are the problem with traditional approach. I've told you that one of the biggest problem is the configuration, but we have to redesign our network, right, Nitesh? Basically, because like I said, in network we have two things: we have control plane and we have the data plane. So if I talk about the control plane and data plane separately, so let me open. So let's talk about the default scenario here. Basically, we have a network, which we call it access layer, distribution layer, and the core layer, right? Today we'll explore the data plane and control plane. We have distribution 1 and we have distribution. Now, first thing you know that a device is having two planes, right? Basically, control plane is designed, right? It will decide that how and where you can forward data packets, right? Processes running on the device like routing, switching, list, R tables, etc. belongs to the control plane. And like you said, if we talk about the data plane, data plane is responsible for forwarding packets received from the end on the basis of information provided by the control. Sorry, data plane cannot work without control plane. So control plane was designed for the data plane itself, right? Now, in the network for the control plane, we have two types of control plane, like we have layer 2 and we have layer 3. Basically, anything which is going to help the data plane is belongs to the control plane. So, right? Like this is my switching environment.
Yes.
All of these links are operating in layer 2 mode. Right, Nitesh?
Correct.
Now, if this user wants to communicate with this user, you have to make few configurations. First thing you have to do is you have to configure an IP address, right?
Right.
10.1.1 and IP address of this user is 10.1.1.2.
Yes.
Now, so the problem is, if this user wants to communicate with this user, you have to make sure that this network is working, right?
Right.
We know that this is a layer 2 network, so you can have a loop here. You can have what? You can have loop, right?
Yes.
So what we are doing, we are running STP. So what is STP now? STP is a control plane protocol. Basically, STP is doing something which is going to help the data plane, right? It is like we learn in the childhood or in the adulthood as well, that if you grow a tree, a tree is not going to eat its own fruits. Like people say, right? Tree doesn't eat its own fruits. Be selfless. Be serve the people like this. So STP is doing what? STP is doing something for the data plane. What STP is doing? STP is building a loop-free topology, right?
Right.
So that users can forward the traffic. Now what STP will do? STP will decide RP port, DP port, block port, DP port, DP, alternate, RP, DP, RP, DP, alternate, likewise, right?
Right.
Now this thing is done by STP. We got the first problem here. The first problem is that we are not able to utilize all the links.
Yes.
First problem. Now, MAC address of this user is A and MAC address of this user is B. So for example, if this user wants to ping 10.1.1.2, what is required? Be packet to this PC, 4 informations are required. Destination IP is required. Source MAC is required and destination MAC is required. But the problem is that we have the source IP, no doubt, which is 10.1.1. We have the destination IP, which is 10.1.1.2. But the destination MAC is
Yes.
the destination MAC is
Yes. Unknown.
unknown, right? The user will send an ARP request. Source IP 10.1, destination IP 10.2. A destination MAC would be OLF, 12 time F, right?
Okay.
And then the type field, which is 0x0806. This is an ARP packet. So user will send an ARP packet to the switch. Now what switch will do?
Switch will flood it to all the.
By default, if we haven't configured anything, so on the switch, by default, it will forward that ARP request to all the interfaces, not on this, because this is an alternate port and it is blocking. Then D1, it will forward it to this, and then switch will forward to all the interfaces. What kind of behavior is this? This behavior flood and learn behavior. This behavior is known as flood and learn behavior, right?
Right.
After this PC will give the MAC address to PC1, then PC1 will get to know, okay, for 10.1.1.2 MAC address is B. Now this time PC1 will encapsulate a packet.
Right.
In which source IP address is 10.1.1. This is an ICMP packet, right? Destination IP address is 10.1.2. Source IP address is A. Destination MAC address is MAC is B. The type field is 0x0800. Then this packet will be given to switch. Now what switch will do? Switch will be having a MAC address table.
Yes.
Right?
Right.
Then switch will forward this ICMP to D1. D1 is also having a MAC address table. Then D1 will forward this packet to switch 1. Switch 1 is also having a MAC address table.
Yes.
Now, as I said, we have to redesign our network. The first problem is that in this scenario, we do not have support of ECMP. You know what is ECMP? ECMP stands for equal cost multipathing. I'm not able to utilize all the available interfaces because of STP. Because of STP. Second problem is that how we will identify or how we will discover the other device. By sending an ARP request, this behavior is known as flood and learn behavior. So if I say I have 5,000 hosts, right, Nitesh?
Yes.
The problem is this switch must know about 5,000 hosts in its MAC address table. D1 should have 5,000 host MAC address, right?
Right. All the switches.
D2 must have. If the number of users will increase, as a result, number of MAC entries will be increased, right?
Right.
And as a result, broadcast traffic will increase in the network.
Right.
Because if you have more users, they'll send ARP request all the time. Yes or no?
Yes.
This is the first problem. This is the first problem. All right.
Right.
Now the second problem is, if we want to control the traffic, first thing we will be doing is the VLAN configuration, right?
Right.
Virtual local area network. So this thing is known as network segmentation.
Yes.
Network segmentation. All right. So if this is your network, first thing what we'll do, we'll segment the network into VLANs. This is not a part of DNAC, but yes, we must have the basics clear. This is a switch, all right, Nitesh?
Right.
And this switch is having multiple interfaces. So you know that by default, all the interfaces belongs to a single broadcast. Domain. So what I did, I've created few VLANs here. We have VLAN 10, 20, 30, 40, and 50, right? So what happened here? Now we have total 5 VLANs, which is equal to 5 broadcast domain. So you will say, okay, What will create? What will get by creating VLANs? So basically, what we will get now, the network is segmented into 5 virtual networks, right?
Right.
By default, a user belongs to a VLAN cannot reach to who belongs to a different VLAN, right?
Right. Right.
You can provide inter VLAN by configuring.
Right.
You can also control the access by enforcing access list, right?
Right.
So by default, from VLAN 10 to VLAN 20, 20 to 30, 30 to 40, and 40 to 50, communication is not allowed. But we can do this thing by configuring the routing. Once you configure the routing, any user who belongs to VLAN 10 can communicate with the users who belongs to the VLAN 20. But I can do one thing. I can enforce the access list or enforce the policies to control the access, right?
Yeah. Right.
But the problem is access list is not a good solution now,
Yes.
because it is very difficult to identify the end user on the behalf of an IP address. Maybe the IP address might be keep changing, right?
Right.
So how we will be supposed to enforce the policies on a user? So by default, in the traditional network, you have only one way to identify a user, the IP address.
Correct.
Or maybe you can have a VLAN. That's
Right.
only. But this is not a scalable solution. This is not going to help you in a large size network, right?
Right.
So we need something can help us to segment the network in a good manner. So the software defined access, not the DNA center we are talking about.
No.
Software defined.
Access.
See,
In perspective, like you're trying to say the advantages of how software defined network segmentation.
yeah. So in this session, we are going to discuss about two things. First is DNA center, and the second thing is SDAccess.
Right.
Like I said, we have to redesign our.
Yeah.
So we are redesigning a network as well as we are deploying a controller. From with the help of that controller, we will be doing this. We will be redesigning a network and we'll keep it in the functional state. So SDAccess fabric and DNA center. So the software defined access is first thing is going to solve the problem, which is the segmentation. How? How is the question? See how it is done today. To create segmentation, customers are doing things like steering all the traffic through firewalls using VLAN, access list, VRF, or deploying an.
Correct.
So you can create VRF also. VRF is virtual router forwarding. Some customers have deployed TrustSec into their network but have found it historically difficult to. Do you have any idea about TrustSec, Nitish?
Not so sharp.
Okay, so basically what is TrustSec? This is a switch. All right. You know that switch is a multi-port device.
Right.
And switch is also known as a plug and play device.
Okay.
So what we do, we don't keep the interfaces in the disabled mode. So interfaces of a switch are always in enabled state, right?
Right.
But it can lead to a network security thing, because
Yeah.
if the interface is always up, anybody can connect to the network.
And I have access.
Yes or no?
Yes, anybody can plug it and have access.
Yeah.
Any user.
So what we used to do in CCNA, at the CCNA level, I'll say configure port security.
Yes.
But port security is not a great solution.
Right. Because if the user changes, it will be difficult. You have to again configure.
Yeah. So port security is not a great solution here. So what we did now, we said, okay, we'll take the help from the ICE.
Radius.
So don't think that ICE is always directly connected with switch. I'm just assuming it.
Yeah, it's
So the only concern is
IP connectivity.
ICE must be reachable, right?
Yes.
So this is my network. The ICE is reachable to the switch. Now, what we said, we'll configuring a feature which is known as 802.1x. All right. 802.1x authentication. So for example, this is user you. For example, this is Nitesh. So I have configured a password, a username here. I said username is Nitesh and password is Cisco. All right. This is just for the demo. Otherwise, ICE is having a password policy and it will not allow you to configure a very simple password like Cisco. Now, when the user will plug in the cable and user will try to send the first packet, switch will say, okay, tell me the username and password. So here the communication will happen with the help of, most of the time we are using radius. Okay. All right, Nitesh. Now, while configuring the authentication, so we have three pieces here. We have authentication, user authentication. We can also perform user authorization, and we can also do the accounting thing as well. So in case of authorization, I can push dynamic ACL. I can push a VLAN from the ICE as well. All right. All right, Nitesh.
Right.
So what I can do, I can ask this switch ICE to put the user in VLAN 20 and push a dynamic ACL in which allow any traffic, permit IP, any N. Okay. This is behavior of ICE while you're configuring 802.1x authentication. So you can configure authentication as well as authorization, and the final product is accounting. Okay.
Right.
But what is trust check? Now the problem is, by default, while we are doing 802.1x, we put the dynamic ACL over this interface. All right.
Right.
So the problem is, if we have 50 users, Switch will have dynamic ACL for each and every user separately, which will increase the size of TCAM table. will increase the size of ACAM table.
Yes.
So instead of enforcing the policy on the switch itself, we want to configure ACL on the router or on the firewall, right?
Right.
So again, the problem occurs. For router or firewall, they can identify a user only on the behalf of IP address. All right.
Right.
Then Cisco come up with a solution. Cisco said that okay, we are adding a new feature to the IC, which is known as Cisco Trust Set.
Yes.
Is a technology designed by Cisco and supported in Cisco ICE Identity Service Engine. It is using a right
Correct.
at the time of an SGT will be pushed and end user.
It will be after the authentication, then the authorization will be detected and pushed, right?
First authentication, then authorization. Okay.
Yeah, on that time.
Yeah. So this security tag will be pushed for the user. So if I come back to this, so if we enable trust check, ICE will push a tag to this interface. For example, you have configured tag HR and value is 0120. Okay.
Right.
So this tag will be pushed to this 0120. So whenever user will send a traffic and switch will send traffic this to further, switch will always add tag 0120.
Right.
All right.
Right.
So router or firewall will be configuring the access list on the behalf of SGT, not on the behalf of
IP
IP. This is the traditional approach and this is the SDA fabric approach, security group tag. All right. Okay. Then we have hundreds of things here.
But this is under traditional, right? SD,
No, SGT is in the SDA fabric.
Okay.
Normally we configure access list on the basis of IP address. All right.
Okay. Okay. Before it was dynamic access list.
Yeah.
Now it is.
It is dynamic or whatever it is, but we are not using SGT normal. But now in SDA fabric, we will be using Cisco Trust Sec for the network segmentation and user identification. All right.
Right.
Now in traditional network, the problem is security is also difficult and time consuming to maintain as customers have numerous firewall interfaces with thousands of lines of access control list to limit traffic flows, because you have to create access list for each and every user, right?
Right.
But in SDA fabric, what we will be doing, we will be deploying Cisco Trust Sec. And on the basis of that Cisco Trust Sec, we will be easily configuring access control list. Today, security as is handled by customer deploying 802.1x and ICE in their networks, right?
Correct.
we have seen great success among customers adopting and deploying 802.1x, but it can be timely process to create, test and roll out 802.1x organization. Why? Means it is difficult to deploy. All right.
Correct.
Because now you have to go to ICE and you have to add each and every switch again and again.
Right.
See, basically what you have to do normally, this is your ICE.
Each and every switch you need to add it to the terminal list.
Yeah, either it is router or switch or Cisco WLC, whatever it is, right?
Yes.
So what you have to do, you have to add each and every device onto the ICE.
Correct.
But now with the DNA Center, it would be a very, very easy deployment. Why? Because all of the devices are already integrated with DNA Center. We just have to integrate ICE to DNA now.
Correct.
Right?
Right. Only one.
Yeah, it becomes easy. So let's see how it done with software defined access. Now, first thing, macro segmentation is created by software defined access via VRF.
Right.
And micro segmentation via Cisco. Like this is your VLAN. All right.
Right.
So at a large level, macro segmentation. I have, for example, I have 10 users or 8 users, whatever. All of these users belong to VLAN 10. I have segmented these users, right? But if I want to create segmentation inside this VLAN, inside this VLAN, the only thing I have is IP address, right?
Right.
Because if you want to divide the VLAN further, you have no way. The only thing left is IP address. You can identify the users on the IP address and you can form the micro segmentation. But in case of software defined access, first of all, we'll use something called VRF to create a segment. Then inside that, we can do what? We can push SGT, security group tag, or micro segmentation. All right.
Right.
Which uses a scalable group tag. SGT see, yeah, this is what I was thinking, that the full form is wrong. All right. It is not scalable group. It is security group tag. To map a user identity to a tag rather than
IPM.
Now, read the second line. It is
writing security rules of this tag improves the readability of the security policy and significantly reduces maintenance, going through thousands of ACL entries to 10 of SDT entries.
right, because while you're configuring access control list on the behalf of IP address, you have to create thousands of ACLs for each and every user, right?
Right.
But now we have deployed security group tag. So instead of configuring ACL on the behalf of IP address, we will be configuring on the behalf of SGT
on the user.
Yeah.
Each user will have one SGT.
Yep. So have you ever done anything with ICE?
Not much.
All right. Software defined SDAccess also automate the process of deploying 802.1x to the fabric. Yes. Okay. Let me tell you what it is talking about. If you have this network, all right, Mitesh?
Yes. Yes.
This is the network we have now. Now, if we do not have the DNA center, or if we are not deploying the SDA fabric, then this is my, for example, R1, this is my R2, this is going to ISP, this is again going to ISP, and somewhere on the distribution switches, I have connected ICE. All right, you can deploy more than one ICE as also for the redundancy purpose. Now, if you want to configure 802.1x authentication for this interface, you have to make configuration on the switch, and you have to make the configuration on ICE as well. So you have to make configuration on switch and ICE, right?
Right.
Just give me 1 second. Okay. Now, okay, Nitish.
Yeah.
So I have gone through the configuration of 802.1x. So basically, what you have to do, you have to go to switch. You have to configure like this: AAA new model, then AAA authentication .1x, default group, radius, AAA authorization, network, default group, or you can say default group radius. All right.
Right.
Then you have to say radius, server, ICE, address IP version 4. Then you have to give the IP address of ICE.
Right.
Then you have to give a key which is used to authenticate the switch by the ICE. Okay.
Right.
Then you have to go to the interface on the switch port, like interface F1/0/1. Then you have to configure this command, switch port host. All right.
Right.
Authentication, host mode, single. Then you have to say authentication, port control O2, .1x PAE authenticator. Right? Exit. And one more command you have to enable in the global configuration mode, which is .1x system authentication control.
Yes. Yes. On the switch. Correct.
Right?
Correct.
Now, who is going to do this? You or me? Who are the network engineer, right?
Right. You have to do it on each and every device.
Yeah, but it will become very, very easy with the help of
The
DNA center. So that's why it is saying that software-defined access also automate the process of deploying. The deploy and maintenance is automated and managed by the DNA center applies and the identity service.
Right.
This is the first thing, which is known as segmentation. All right.
Right.
Then second, we have host mobility. Now, what is host mobility?
Host mobility, user irrespective of any site in the campus network, his policies will be the same, his usage will be the same based on his user credentials.
So yes, like you said, this is a switch. Again, switch 2, access 1, access 2. and this is my user.
Right.
So for example, 0/1, right? And this is interface 0/2. This is interface 0/1, and we have user here 0/1. Sorry, 0/2. For example, MAC address of this user is A. MAC address of this user is B. So if I talk about switch 1, switch 1 will be having entry on 0/1 and MAC address.
Right.
Then this switch will forward traffic to D1. Then D1 is having entry on 0/2, that user is A. Then D1 will forward this traffic to switch 2. Switch 2 is having entry that on 0/A I have user.
Yeah.
Now,
Yeah.
in the reverse order, we have user B. So switch 2 is having entry on this interface that we have user B. Then this switch will forward traffic, for example, to D1. D2 is also having entry on 0/1 B.
Right.
Then D2 will forward to this. And for example, this is my 0/2.
Yeah.
So switch is maintaining the MAC address table, which stores
Right.
the information of end user, right?
Yeah. Right.
What if this user from here wants to connect to this now, right?
And then it will start flooding. And then
we, yeah, very good. And we have seen this behavior mainly in the wireless network.
Yes.
That's why we come up with the idea of wireless, because in wired network, mobility is difficult.
Right.
But in case of wireless, a user can easily move from one switch to another switch.
Right.
Yes or no?
Correct.
Let's see how we deal it with today's network. How it is done today. Today, when a user roams throughout the network, their IP address changes, making it difficult to base security policies on, and creating complex IP schema too.
Right.
First thing is that if the user will be relocated, first thing will be changed the IP address. And now what it is saying, if you have implemented the security policies on the basis of IP addresses, then it would be very difficult because you have to change it now. First problem is this, and second problem we have discussed here, right? We have to recreate the MAC entries, right? Because the user with a MAC address who was connected here now is connected on switch 2. The MAC address table must be updated. Must be updated.
Yes. Okay.
So how we done it today? User can seamlessly roam over layer 3 network while maintaining the same IP address by using as the control. Now what is list? Locator, ID, separation, it was designed to reduce the size of internet routing table. Okay. But now we are also using Lisp in SDAccess networks. Okay, Nitesh?
Okay.
And it would be very clear to you when we'll discuss about Lisp. We will discuss about the control plane using Lisp. Okay.
Okay.
In this solution, security information is achieved using right. You see the second problem, based security policy on. If, for example, just for an example, if I think that IP address has changed, okay,
Sorry,
but I haven't enforced the policy on the IP address. If IP address will change, no matter, as it will remain same. Yes or no?
Yes.
Still the user is belongs to the same group. So the IP address, okay, might be IP address has changed, but the security group tag is still same. So with this model, you can use very large IP sets without worrying about broadcast term or using IP addresses for security.
So
enforcement.
right now we don't need to worry much on IP side as well.
What?
We don't need to have very large ports. Okay.
Your voice is not loud.
Can you hear me?
Yes.
Yeah. So right now in this solution, we need just, even if the site is different, the IP addresses can be shared. Okay. I understood. Understood.
Okay. All right. The second problem is, third problem is automation and orchestration. See, in today's network, or you can say in the traditional network, customers use many different systems to help automate and orchestrate the deployment of a network, right? Most of our customers still manually deploy their networks by this CLI, which can take over a week to stand up a site. Yes or no?
Yes.
Including provisioning VRF, configuring dynamic routing protocol, configuring switching features, and configuring 802.1x. Using what?
CLI.
Using
CLI.
How we will do it with the SDAccess? The entire software-defined access solution is deployed and managed by Cisco DNA Center. Okay.
Okay.
Providing customers with a single pane of glass for all network tasks. DNA Center can automate all of the deployment tasks, which would normally take over a week, into a few.
Okay.
And the last thing is network. It is very, very important, right?
Yes.
See,
mandated.
You know that if you are going to a showroom, if you are going to a cafe, if you are going to, you can say, any hotel, you always see the cameras, right?
Correct.
Security cameras plus security guards plus the other staff.
Yes.
They are keeping an eye on you. They have the full visibility what you are doing there.
Yes.
Network visibility is also required. We should know that what is happening in the network at this moment.
Yeah.
What is the activity of a user? What a user is accessing, what a user is doing in the network, right? This thing is very, very important. So again, normally how we do it? We do it with the help of syslog, we do it with the help of SNMP, we do it with the help of NetFlow by deploying on each and every device. But let's see how we will do it with the DNA Center. So network visibility. Today, customer must use third-party tools, right? To try to gain visibility into their network, but generally lack meaningful, actionable data.
Correct.
If a user calls into a customer help desk, gaining visibility into historical network issues is near impossible, making troubleshooting a difficult and time-consuming task. So how we do it with DNA Center? Like I've shown you in the last section, we have two components in DNAC, NDP and NCP, right?
Right.
Cisco Network Data Platform, an optional component of software-defined access, delivers end-to-end visibility, analytics, and troubleshooting tools. We are not supposed to see it right now, okay? But just let me admin Cisco. So I'm sharing a new tab. Can you see the DNA Center?
Yes.
If I go to system settings, and you can see system 360, right?
Yes. Yes.
Host, how many hosts are there? Is there any availability? Cluster tools.
Okay.
System management, backup, application health, identity service engine. You can see in the system 360 plus. A help desk employee can get a 360-degree view of the client and device historical experience on the network. NDP can show issues and trends related to things like device onboarding, app experience, and more. For example, NDP could identify a wireless issue in the network that correlate to the user ticket to quickly identify and resolve the ticket. So if you go to the DNA Center again, and for example, if I go to the assurance and I go to the overall, you can see that how many network devices are there,
yeah,
how many
can you give me a
routers, how
moment?
many port, distribution access, right?
Can you give me a moment? One moment.
Okay. All right, all right. So you can see that it's showing that how many devices are there, who is connected, top 10 issues types, right?
Right.
So the DNA Center provides you the full visibility inside your network. All of these services are offered by your DNA Center.
Yes.
So now in next session, we'll be starting with software defined access, where we'll discuss that what is Cisco software defined access. What does SDAccess mean? So Cisco SDAccess is the foundation for a new era of, like I've given you the introduction of intent-based networking in the last class. What does it mean? It means that your intention must be clear. All right. How the configuration will be deployed, it is the headache of
DNA Center.
DNA Center. But your intention must be clear. That okay, I want this. That's all.
Right.
All other things will be taken care by DNA Center itself. Cisco SDAccess is an innovative fabric-based network infrastructure to provide automated network and policy configuration, dynamic host mobility for wired and wireless, identity-based macro and micro segmentation, virtualized, multicast, and layer 2 broadcast.
Right.
Talk about each and every